Hello YouTubers. Today we have the ICOM IC-735 here on the desk, and it came in with trouble on the frequency dial, so frequency is jumping or doesn't work in the right direction or whatever. So let's check if we can reproduce it. Yeah, it's already connected to 13 volt, and so we can switch it on. Okay, so what have we? Oh, S-meter light doesn't work as well, so but that is another story. So what is with the frequency? Oh yes, oh yes. So it should go up, but as you can see, sometimes it jumps back. So 3, 4, 3 and 2. So that means it is jumping, and on the other direction it's going down for the moment in time. But yeah, in any case, something is wrong, and as well there is something with the dialing speed. So this model has a special a special innovation for these days. So the tuning speed should go up by rotating it faster, but I can rotate it as fast as I like. It seems to be always the same, and if you dial it very slow, it should go slow, and when you dial it fast, speed should go up, so that you can move on quicker. But that doesn't work as well. So that is, yeah, that is as well an issue. So let's try to change the band. Oh. It's jumping as well, so I'm turning up and it is going down. Yeah, so there's something wrong. So let's see what it is doing with the mic. So there are up and down buttons as well, and if I push it here, I have to go back. Okay. Oh, up button works, and the down button works as well. So yeah, for me it seems that there is something wrong with the encoder switch, and yeah, this special encoder switch is well known for producing trouble, and it is very rare on the market, so it's not easy to get. And the component itself, so with this dial, with this encoder, you can really dismantle it up to the point or down to the point where you can directly see the infrared diode and the transistors. So that is really a delicate unit, so we have to check whether we are able to simply fix it. Okay, and transmitting. So okay, so that seems to work on the first check. Okay, so next to do is open it up and check the quadrature code, if we can see the jumping as well. Yeah, and then we are at least at the point where we have to check this encoder switch. Okay. So I have now opened it up, and this plug down here, here we can see it. This plug down here is the plug which comes from the frequency dial, and I have channel A and B from the encoder connected to my oscilloscope, and you should normally see the quadrature code on the scope while I'm dialing. So when I start dialing, you should normally see both. And now I have a look. So now I'm dialing forward, and what you can see, I'm still dialing. Now changing the direction, nothing happens. And yeah, you see one channel, but no, the second is missing. There we had both, and that is what we want to see, both channels together, and we need to see the 90-degree phase difference between the both channels, so then we can be sure that it would work in a correct way. But as you see, so I'm permanently dialing, so I do not stop dialing, and yeah, what you see is that that it is not really picking it up, so there is definitely something wrong with the encoder, and I guess yeah, first of all I have to take the encoder out, and we'll have a first look, but as I said before, this is a very, very delicate encoder, so the best would be to put a new one in, because additional to that it is very delicate. Even the single parts which are on the little PCB, we will see later, are very hard to get, so I guess I need to think about another solution. So this is that is not very nice. So that is really not very nice. So that is the reason why you see the display jumping. In the moment it is going up, but then suddenly you can see it going down, so we are not able to now we have the 170, but anyway, so it is not really picking up the dialing signal, and yeah, that is what you can see here. So that is a problem, and even when I go left, so and it should go permanently down, but it doesn't really work. So it is it's not what we want to see. So I've taken the encoder out, and yeah, you can see it here for its own, and yeah, this is a version where you can take this little PCB out of this mechanical block, and on this PCB you have all the photo elements, and you have, as you can see here, additional transistors and capacities and whatever. So it starts to be complicated if you are losing this screws, because then you can move this little PCB just a little bit, and this little movement already can make it worse, or in some events may be a bit better, but I guess there is a photo element failing, because we have seen that the quadrature code is not really picked up as it should. So therefore I have built here on the breadboard a little test circuit, which is now connected to the encoder, so that we can check the encoder by itself, and yeah, breadboard is connected to the power supply, which supplies the encoder with 5 volt DC. So that is the same what we have on the board, so that is a normal TTL voltage where the encoders are working on. So, and yeah, I have connected the both channel A and B to these probes, and the probes to the oscilloscope, and now I'm losing focus, and now I'm dialing, still losing focus, so that is not very nice. But anyway, maybe you can see that it is not that there are not both channels available. So sometimes both, and sometimes not. So yeah, I think I will connect it to the digital scope as well. Maybe we can see it a bit better to judge what the result is. So once again, I have now connected my probes to the digital oscilloscope, and now I'm turning, and yeah, what you can see is the same result we had before. We do not have both channels together, which is necessary to have the quadrature code working. You see, it is only sometimes that both channels are switching on, and if you have seen my video before where we repaired FT-747 von Yaesu, there we were able to see clearly the both channels working. So so for this I have to say there is definitely a problem with the encoder, and you know, even if I take it out, and I guess I will to show how it looks inside, but well, we have here the infrared LEDs, and we have here the phototransistors, and in between there is a foil from the encoder, and I believe that there is something wrong with well, one of the elements. It only works intermittent, and problem is you can't either get the whole encoder from ICOM because it is too old. It is not any longer on stock, and yeah, on the other hand, we do not really get the spare parts itself, so because they are obsolete as well. So we are in trouble, and I guess we need to look for another solution, but yeah, this doesn't work. So I have now put the encoder here in the little fixer and the little holder, and just with the pressure on it, you see that now sometimes both channels are obviously working, but not constantly. So still the same problem, maybe a bit better. So therefore I thought we carefully open up the screws. So first one, but we don't take it out completely. We just open it a bit, and as I said before, by simply open up the screws, you can see that now I can move a little bit the PCB, and I'm still moving the PCB a little bit, and you see the blue channel, so the second channel switching. So that is a clear indication that simply by moving the PCB you are disleaching it, and that is very, very critical. So therefore the plan is now see if we can find a position where the encoder may work as it should, and therefore I carefully fasten the screws again, but only in a way, bit more, only in a way that I'm still able to move the PCB. And yeah, so it is still too much play. So maybe now that could be better. And what we can see is that it might work a bit better. It might work a bit better, but still, still not as it should. So we are still losing intermittent one channel. So yeah, that is you have really to fiddle around and see if it works, but as far as I can see it, we are not simply able to to fix it by moving the PCB. So next would be to take it out, but yeah, the risk is very, very high that you damage it completely, simply due to the fact that here in between, so these are the LEDs and here are the phototransistors, and in between there is a foil mask, and this mask which is running here in between is very, very thin and very sensitive. So only one little fault in during we are taking the PCB out can completely damage the foil mask. So we have to be very, very carefully. So one check we should do before we go ahead. This is a schematic of the encoder, and what you can see here are the infrared LEDs, and these are the photo transistors, and you can see here the quadrature signal with the 90 degrees phase shift, which should be available when you are turning. When you go forward, it is like this, and when we go backwards, so this is changing the phase to the left. But what I want to check is with 4.7 volt, we should have 2.3 volt at both infrared LEDs, and we should have 1.2 volt at one LED. Both should be on the same level, and this resistor here, the R1, is only to control the current flowing through these both diodes. I have put it exactly on 4.7, and The red one over here is the 4.7, which is 4.7, and we have here the LEDs. So this is ground, and the little resistor is can we see it? It is down under here. So over there, it's not very good to see, but anyway, we are here at the both diodes, and as we saw in the schematic, we should have 2.3 volt at this point, and what we can see, it is 2.3. Very good, very close. So if we now jump over to the second, we should have 1.2, and what we have is 1.18. Yeah, so that is pretty close. That is pretty close. Very nice. So that should be okay. So yeah, the current and the voltage through the LEDs seems to be okay. So now next will be to dismantle it and see whether we can find something inside. Yeah, so I have to take these screws out, but I will not do it through the camera because that is much too delicate. I will do it without camera, so that is much too critical, due to the fact that you simply can damage the complete unit. So let's check. So here is the little PCB which I have taken out, and yes, it's a little bit difficult to show on the camera, but what we can see here is this both are the DS2 and the DS1. DS2 is this, and DS1 are the infrared LEDs, and the Q1 and Q2, this is the Q2, are the photo transistors. And as I said before, the foil mask is running between this photo elements, and in the mask, I do not know whether we can see it, but maybe a little bit. It is very, and I really should not touch it, but yeah, you maybe see it a little bit. This is a very thin foil which get turned, and there are 250 slots in this mask, and this mask is interrupting the light which is shining through, and is received by the phototransistors. So the phototransistors are receiving the light when there is a slot which let the light passing through, and that will give us the signal. So that are the pulses we can measure what we have seen. Yeah. So maybe I can a little bit align the diodes, but I do not really think that we can fix it. I still believe that we have a intermittent dropout, which can be connected to the age of these elements, and well, on the other hand, this mechanic is not really good to survive next I don't know, 5 or 10 years. So therefore I guess it is a good idea to look for another solution, because furthermore it could be that the little mask inside can be disleached as well, and that makes it even more delicate and complicated to leach it inside. So, well, maybe I really should look for another solution. Maybe I try one of these little encoder switches which I have already put into the little FT747, but yeah, there is obviously a second problem which we have to face. Normally this optical switches are open collector, and this is emitter output. So we have inverted signal at the output of this strange, and furthermore this little transistors here are so-called digital transistors. These are moreover switching transistors which have resistors already inside. So it is not only the silicon NPN transistor, but rather more there are two transistors integrated in this housing as well. And that is a second challenge. I do not know whether these transistors are fully working, or whether they make or produce the intermittent interruption. Problem is we cannot get the same type, because the type is obsolete as well. So that is again a challenge to cover. So after all, I have decided to start with this new optical encoder, and if it is possible to get it working, this is definitely a better idea than to repair this old encoder with all the difficulties we are facing. From the mechanical side, it looks like that I might be able to fit it in place. So the shaft seems to be long enough to place it in front of the transceiver, so that seems to fit. So the shaft is obviously long enough, so that should work. And yeah, electrically I have to check it, due to the fact that these encoders are naturally working with open collector, and that is different to what we have here, so that needs to get revised. But important for the start is that it is an encoder with 256 cycles per revolution. So that is what we need, because the old one has 250. And yeah, now I'm going to build up a test circuit, and we will check if we have then the quadrature signals as we need it for the transceiver. So I've built a test circuit on the breadboard. So I've connected the encoder, and what we can find here is the inverter circuit, which is necessary to let me show it here. So we have, first of all, the non-inverted signal, which is here and here, and then we have an inverter here and here, and this feeds the OR and AND gather. So in conjunction with this transistor and the inverted signal and non-inverted signal, we can switch between the two speed levels. So depending on what is available on the input of this circuits, we will have a normal pulse, which will be counted here in the integrated circuit 7, or if we go very fast we get it doubled, so then it counts more pulses, and the speed, so the dialing speed, get increased. So therefore we need this inverter, and the inverted are built here with these little transistors and the resistors, and the encoder dial is connected to this circuit, and I've connected the oscilloscope to the inverted signal, so that means I have connected the oscilloscope to A and B, which is on the breadboard, yeah, here and there. And well, now when I go and start dialing, so you can see it. It's a bit difficult here to get it done with one hand, but you can see that it is now working very nice, and you can see the phase difference between channel A and channel B of 90 degree. So that is exactly what is needed to get the information to the processor in the transceiver. So what we can see here actually is that the circuit is working, and with the new encoder it is back to what we want to see. Yeah, and it depends on the speed what I'm dialing. Now I'm dialing, it's a bit difficult. Yeah, now I'm dialing fast and faster, so that is the speed, and as slower I get, you can see the frequency changing. And yeah, as I said, with a non-inverted signal, which are here directly coming from the encoder, and the inverted signal, which is behind this little inverted transistors, I have this both signals, which is not inverted, which is here, and the inverted, and both are going to this devices, and depending on what this transistor, the Q4, is switched to, so if it is switched to, or better said, if we are dialing very slow, this transistor is switched, and we have always a high at these inputs, and therefore we only get a pulse. And when both are working, inverted and non-inverted, then the impulse at this point E is doubled, and we have very higher counts in this counter, and depending on the counts, the CPU is switching to a higher speed for dialing. Yeah, so far what I can say is it is obviously working with this circuit, so that is quite nice. And yeah, I will try to bring the circuit into the transceiver. I leave it here on the breadboard. I just want to put the original wiring, which is here still on the old one. So I will disconnect it and connect it all the wires to the breadboard, and then I can put it back in place, and we can have a look if it still works on the real circuit. So that means does it still work in the transceiver? So test circuit in place. So I have connected the original connector, which is down here on the PCB. I have it connected with the little circuit here on the breadboard, and to the circuit is the encoder switch connected. So now we can perform a live test with the circuit on the breadboard connected to the radio. Yeah, and the encoder switch, I've just fixed it here, that it cannot move away. Okay, so can I get both? Maybe. So when I am turning very slowly, you can see on the display that frequency is going up, very nice, and going down when I turn counterclockwise, and it's doing its job very good. And what you can see as well, so I'm going here a little bit closer to the display. So now I'm moving it very slowly, and when I start turning it faster, you recognize that suddenly the speed goes up. Look at this. So that is a invention by ICOM, as far as I know. So they invented it in these days. So yeah, that is the point. If you turn very slowly, it moves very slowly, right? And if you start turning it faster, dialing, it's getting faster. So let's check the other functions. When I push the hum button, I should be able. Can I get both again? Looks like. Yeah. So 17 meter, 15 meter, 12 meter, 10 meter, 160, 80 meter, and 40 meter. So as you can see, the switching is working again. Very nice. So what we can say so far is that yeah, it is obviously working. So what we have to do next is put the encoder switch and the little circuit here onto a PCB, and then yeah, so that is what I have to consider right now. I need I guess a plate which we can screw on here, and in the middle the switch, and yeah, somewhere I have to place the PCB where I have to put the little circuitry onto, and yeah, that neat. I have to think about it, because when you look through, you see that there is the front panel PCB, and we need to find a way to get the new encoder switch to this plate here, and as well the little circuitry. So that is next. But first, or before I can do anything else, I have to put the circuit on a little PCB, and then we have to test the PCB, and if that is working on a proper PCB, then we can start putting it here back into the radio. But anyway, what we can say so far is that with the new encoder, it is definitely working. So yeah, that is great. That is great fun. I like it. I like it very much. So it was definitely the right decision to order a new one, even that we have all this circuitry which needs to get on a new PCB, but we never would get this one into proper operation. So that it is not worth to spend any longer on this old thing with all the disadvantages I have already told you before. And yeah, so therefore I'm now sure it was a good decision. It is really a good decision to have it done like this. Okay, as I told you before, we need to find an adapter to put this this new encoder inside, and so therefore I made a metal plate which I gonna fit in here, and I screw it on the old position, and then I can fit the encoder in this metal place, in this metal piece, to hold the new encoder. So that is what we have to do. And secondly, when we have a close look into here, we see that yeah, you know, the place So the hole was a little bit too small to fit the new encoder inside here, and therefore I had to cut out, can we see it? Yeah, I had to cut out the hole a little bit that the new encoder fit, and yeah, that was a bit critical, because right down here there is a trace on the PCB which I had to sacrifice. Nah, I mean, I still have the connection, but you know, this trace is now very, very thin, and I think I have to put a wire in place just in case. But yeah, that is not a problem at all. So now the encoder fits into the hole, and when I have put the plate in place, then we can fix it. And yeah, next will be to bring to produce a little PCB with a circuit to get the new encoder connected to the radio. So that will be next. So new metal place, new metal holder is in place that will hold the new encoder. So that is installed, and next is to produce the little PCB to connect the new encoder to the radio. Here is now the new adapter PCB, which has now fitted to the encoder, and yeah, there is the original plug, and so now we have the same circuit here on the little board as we have tested it here on the breadboard. So that is the same circuitry which is now on this little PCB, and yeah, that should work right now. And next is to plug it into the radio and see if it works. Our switch is now connected back to the radio, so you can see it here. Radio is switched on, and yeah, here's our little encoder, and I will check if I can show both. Yeah, as you may see, it's working pretty much as it should. So if it goes fast, you see I have the high speed mode, and if you turn it very slow, so that is really step by step, then you can really change the frequency step by step, no problem. And you can go back as well, so down and up with the frequency. Yeah, as you see, all the effort made sense, and the new little adaptation worked, and yeah, so frequency dial is now usable again, and that is very nice. As you see, it works pretty nice without any problems, so that is what we want to see. Yeah, by the way, I have opened the old one, and this is the slot foil, but I believe it is not really, you cannot really see it on the video, I guess, but yeah, so that is the circuit. I have taken the wiring here from the old encoder to wire it directly to the new one, so that is what I have done. And yeah, our adapter plate is also in place, so next will be to fit it back into the mechanic, and then I have to clean the glass here a little bit, so there is some dust behind it from drilling and cutting out the hole, and yeah, so I presume we are reaching the end of the story. Everything is working pretty nice, so there is no jumping anymore, and it is working as it should. Wonderful! The new encoder is installed, and with this little rubber rings I can adjust how strong it is to turn it. Originally it is a bit too easy to turn, so that might be not that good, but when I put this rings on, these 3 rings, and then I put this back, then I can by the pressure of how hard I press it back and screw it very strong back to the shaft, then I can adjust how strong it moves. So that works pretty well, and that's a nice solution to adjust this and how you may prefer it. So that is very easy. When you put it back and adjust it, and then it is very nice. Finally, that is the end of this repair. As you can see, dial knob is back, and it is adjusted, so now it is running very nicely. You see the frequency is moving as it should. It is not jumping anymore, so everything is as it should. So we can also switch the channels, not the channels, the bands, and yeah, you can see that is moving and working as well, very nice. And that means this repair is finished, so the only thing I have to do is to put all the parts back and put it back in its box, and then it is ready for another couple of years. So hope you enjoyed it, and yeah, if you like it, thumbs up. Thank you. Bye.